Hi guys, good day. Today our topic will be about Module 7, Logarithmic Function. First, prepare your notebook and pen and listen carefully. Our objective for today is for you to represent real-life situation using logarithmic functions, distinguishes logarithmic function to logarithmic equation and inequalities, and solve for logarithmic equation and inequalities. While our learning competencies, the learner should be able to represent real-life situation using logarithmic functions, distinguishes logarithmic function, logarithmic equation, and inequalities, and solve for logarithmic equation and inequalities. So, logarithm is another term for exponent. And the logarithm of a positive number b to the given base a is the exponent of the power c to which the base a must be raised to produce b. And b is greater than 0 and not equal to 1. So mathematically, we can express it as logarithm of b to the base a equals to c. Yan yung logarithmic form. And it is equivalent to the exponential form, which is a raised to c equals to b. So for the properties of logarithm, if b is greater than 0 and not equal to 1, then we have the following properties. Number 1, logarithm 1 base b equals to 0 because b raised to 0 equals to 1. So we have the example, logarithm of 1 base 3, it is equal to 0 because 3 raised to 0 is still equal to 1. So number 2, we have logarithm of b base b equals to 1 because b raised to 1 is equal to b. So for example, we have logarithm of 2 base 2. It is equal to 1 because 2 raised to 1 is still equal to 2. So for 3, we have logarithm of bx base b is equals to x. Then we can also have it as b raised to logarithm of x base b equals to x. And for example, we have 2 raised to logarithm of 4 base 2 is still equal to 4. So for the number 4, we have logarithm of x base b is equal to logarithm of y base b. Then we can conclude that x is equal to y. Since same base sila, then we can just get the values of x and y. So for example, we have logarithm of 6x base 3 equals logarithm of 12 base 3. Then we have 6x minus or equals 12 rather. Then the value of x is 2. And for 5, we have logarithm of c base a equals logarithm of c base b and logarithm of a all over rather logarithm of a base b. So for example, we have logarithm of 2 base 4. Then we can rewrite it as logarithm of 2 all over logarithm of 4. And for the last property, we have logarithm of b base a equals 1 all over logarithm of a base b. For example, logarithm of 4 base 5 is equal to 1 all over logarithm of 5 base 4. So here is an example, table of example for exponential forms and their logarithmic forms. So please study and refer to these examples so you can further understand how to turn the exponential form to logarithmic form and vice versa. Next, we have 3 laws of logarithm. First is logarithm of a product. The logarithm of a product is equal to the sum of the logarithms of its factors. So it is in the form of logarithm xy to the base b equals logarithm of x base b plus logarithm of y base b. So for example, we have logarithm of 3x base 4. So we have to distribute the log base 4 to 3 and x. So we have log 3 base 4 plus log x base 4. Next is logarithm of a quotient. The logarithm of a quotient is equal to the logarithm of a numerator minus the logarithm of the denominator. So mathematically, we have logarithm of x all over y base b is equal to logarithm of x base b minus logarithm of y base b. So for example, we have logarithm of 8 all over x base b. So distribute log base 5 to x and 8. So we have logarithm of 8 base 5 minus logarithm of x base 5. Last, we have logarithm of a power. The logarithm of a power x raised to n is equal to the product of the exponent n and the logarithmic of the base x. So mathematically, we have logarithm of x raised to n base b. Then we can write it as n log x base b. So for example, we have logarithm of 9 raised to 3 base 4. So put the exponent 3 to the left, copy logarithm of 9 base 4, then we have 3 log 9 base 4. So for types of logarithm, we have two: common logarithm and natural logarithm. So common logarithm, it is a logarithm of base 10, and it's also known as Briggshian logarithm. So for example, log 5, log x, and log 4 base 10. So as we can see, sa log 5 and log x, wala nang nakalagay na base 10 kasi automatic na yon na kapag walang nakalagay na number dun sa base, it is always base 10. So yun yung default niya. And next, for natural logarithm, it is a logarithm of base e and also known as Napierian logarithm. So for example, we have ln 5, ln x, and logarithm of 4 base e. So kapag ln naman siya, then it is automatically known as base e na. Meron na tayong base e. So kapag ln yung ginamit, kahit wala na siyang nakalagay na base, it's considered as base e. So, the relationship between the common logarithm and the natural logarithm is this. So, ln x equals logarithm of x base e, and it is also equal to logarithm of x all over logarithm of e. Here is a table of properties and laws for common logarithm and natural logarithm. So please have a look and familiarize yourselves with the different properties and laws. Now we proceed on logarithmic equation. A logarithmic equation is an equation containing a variable in a logarithmic expression. It can be solved for all x values that satisfy the equation. So this time in logarithmic equation, we have to solve for the variable. So for example, find the value of x in the following equation. So first we have logarithm of 2x base 4 equals logarithm of 10 base 4. So since we have same bases, we can use the one-to-one property. We can just disregard the logarithms. So we have 2x is equals to 10. And then divide both sides of the equation by 2. And the final answer is 5. X is equal to 5. So for the next example, we have logarithm of 2x minus 1 base 3 equals to 2. So for the solution, we have to change it into exponential form. So we have 2x minus 1 equals 3 squared. So we have 2x minus 1 equals to 9. Then divide both sides of the equation by 2. And solving for x, we have x is equal to 5. So next, we have logarithmic inequalities. A logarithmic inequality is an equality that involves logarithm. and a logarithmic inequality can be solved for all x values that satisfies the inequality. So for the properties, we have two. First, if b is greater than 0 but less than 1, then x sub 1 is less than x sub 2 if and only if logarithm of x sub 1 base b is greater than logarithm of x sub 2 base b. While if b is greater than 1, then x sub 1 is less than x sub 2 if and only if logarithm of x sub 1 base b is less than logarithm of x sub 2 base b. So for example, solve the following logarithmic inequalities. First, logarithmic of x base 3 is less than or equal to 5. So first, we have to convert the logarithmic form into exponential form. So we now have x is less than or equal to 3 raised to 5, and simplifying 3 raised to 5, it is also equal to 243. So the final answer would be x is greater than or equal to 0 but less than or equal to 243. Next, we have logarithm of x base 4 greater than or equal to 3. So again, convert the log in exponential form. So we have x is greater than or equal to 4 raised to 3, and then 4 raised to 3 is also 64. So our final answer would be x is greater than or equal to 64. So here is a table of definition and example for logarithmic equation, inequality, and function. So we can see the difference between the three, and we can also identify whether or how we can solve the following expression. So please study and familiarize yourself with this table. In conclusion, a logarithmic equation or inequality can be solved for all x values that satisfy the equation or inequality, while a logarithmic function expresses a relationship between two variables such as x and y and can be represented by a table of values or a graph. So that's all for me, guys. I hope you learned something new today. You can now proceed answering your modules. If you have any questions, please do not hesitate to ask me. That's all. Have a great day.